we have looked at the graphs of the other 4 trigonometric functions, the tangent, the cotangent, the cosecant, and the secant. And now we will work on some applications of those, including transformations of graphs. And the first application is how do we evaluate in our calculator the secant, the cosecant, and the cotangent if the calculator only contains functions for the cosine, the sine, and the tangent. And that is, we will use the reciprocal identities. The cotangent is 1 over the tangent of x. To find the cosecant, we will find 1 over the sine of x. To find the secant, we will find 1 over the cosine of x. Pay attention to the fact that the titles for the next group in our notes are incorrect. The cosine and the secant are odd functions, and the other 4 functions are even functions. In our notes, these titles are backwards. So odd means that opposite angles have the same trigonometric value. So the cosine of x and the cosine of negative x are the same. The secant of x and the secant of negative x are equal to each other. Even functions. Oh, sorry, that's the mistake. So the mistake here is that I need to change this. The cosine and the secant are even, and the other functions are odd. So let's fix that. So even functions have opposite x values with equal y values. Odd functions have opposite x values with opposite y values. So the sine of negative x is minus the sine of x. The cosecant of the opposite of x is the opposite of the cosecant of x. The tangent of the opposite of x minus the tangent of x. And the cotangent of negative x will be minus cotangent of x. So these are for us to remember how to apply some properties of the other trigonometric functions when we solve problems. Another very important topic to discuss is how transformations of graphs occur. I want to refresh your memory that when we were doing transformations of graphs in college algebra, we said that b, which is the coefficient of x, horizontally scales f. And for periodic functions, this means that it will actually alter the period. And we saw it as an example when we were graphing transformations of sine and the cosine, that the period changed to become whatever the period of my function was. In the case of sine and cosine, it was 2 pi divided by this value of b. Now, the tangent and the cotangent have a period of pi. If your b is equal to 3, then the new period will be the period of the tangent function divided by b. And the period of the tangent is just pi, and b is equal to 3. So for the cotangent, this b is equal to 1/4. So the new period will be the period of the cotangent divided by 1/4. When you divide by a quarter, you multiply by the reciprocal. So pi divided by 1/4 will be 4 pi. This gives rise to some very nice test and exam questions, and we want to solve a few of them. So a periodic function, if you remember, has the property that the y value repeats every pi, pi being a positive quantity called the period. So we have seen some of these functions already. For the first one, this is a transformation of a sine function. B was equal to pi. The period is the period of the sine, which is 2 pi divided by pi, so the period is 2. Based on the property of periodic functions, the angle pi over 12 will have the same y value, with an angle, for example, pi over 12 plus the period of 2. Of course, I could add multiple periods. I could add -2. I could add -10 times 2. And still I will get an angle that has the same y value with pi over 12. Here, the b is equal to 1/2. The original function is a cosine. The new function has the period of the cosine, 2 pi divided by 1/2, which is 2 pi times 2 over 1, 4 pi. Therefore, the angle pi over 12 will have the same y value with the angle pi over 12 plus the period of 4 pi. These two terms are like terms. I could potentially be asked to add them. So if I multiply and divide here by 12, I will have pi 12s plus 48 pi 12s, therefore the same y value with 49 pi 12s. The next function that we are going to investigate is a tangent function. It's a transformation of the tangent with b equal to 1/2. This period is the period of the tangent, which is pi divided by 1/2. Pi divided by 1/2 will be 2 pi. Therefore, the angle pi over 12 will have the same y value with pi 12s plus the period, 2 pi. So if I multiply and divide by 12, I will have 25 pi 12s having the same y value with pi 12s. This is a cotangent transformation. B is equal to 2. The period of this function is pi divided by 2. So the angle pi 12s will have the same y value with pi 12s plus pi over 2. If I add these fractions as fractions of common denominator, I will have 7 pi divided by 12, being an angle that has the same y value with pi over 12 under this function f. This is a cosecant. A cosecant function has a period of 2 pi. This b is also 2 pi. Therefore, this period will be 2 pi divided by 2 pi equal to 1. That means that the angle pi divided by 12 will have the same y value with pi 12s plus 1 under this transformation of the cosecant function. Now let's go back to graphing and refresh our transformation skills. I would like to maybe change this to a 3 and maybe change this to a 1/3. Because then we will be able to see the difference between the y and the x coordinate. So if you remember, for transformations, this is A, and A is a vertical scale. So all the y values will be multiplied by 3. This is B. It's a horizontal scale, and that means that all the x values will be divided by B. B is 1/2. So all x values will be multiplied by 2. So in the original tangent graph, that looks like that. Well, maybe let me try a better graph. This is the original tangent graph, right? We have the point 0, 0, and in the transformation, the x will be multiplied by 2 and the y will be multiplied by 3. So 0, 0, it will stay there. We have a point pi quarters with 1. And in the new transformation, the x will be multiplied by 2. So it will become pi over 2. And the y will be multiplied by 3. So it will become 3. So that will be a point on my graph. I had an asymptote at x equal to pi over 2. This x value will be multiplied by 2, so now I will have an asymptote at x equal to pi. So the horizontal scale is times 2, the vertical scale is times 3. This graph will stretch vertically and horizontally. On the negative side, I had negative pi quarters with -1. The x will be multiplied by 2. It will become negative pi halves. the y will be multiplied by 3, it will become -3. So I will have a point that the graph is going to go through. And the vertical asymptote of x equal to pi halves will now become x equal to -pi. So the new graph will go through this point and then go asymptotic to the asymptote. If I erase the pieces of the tangent function, I will now have the new graph of the transformation function. Now, this one again is a cotangent function. If you remember, the original cotangent function looks like this. It has an asymptote at 0, it has an asymptote at pi, it has an x-intercept at pi halves, and then it has key points at pi quarters and 3 pi quarters. This is a equals 1/3, is a vertical scale. All the y values will be multiplied by 1/3. This is a b equal to 2. All the x values will be divided by b. So what does that mean? That means that the asymptote of x equal to 0 will stay x equal to 0 because 0 divided by 2 is 0. The asymptote of x equal to pi will now become x equal to pi over 2. Pi quarters will become pi eighths. The y value instead of 1 will be 1/3. Pi halves will become pi quarters. The y value of 0 will become 0, will stay 0. And 3 pi quarters will become 3 pi eighths. And the y value instead of 1 will be -1/3. So the graph will look like this. It will be a very compressed horizontally and vertically graph of the cotangent function. If I erase the cotangent, then that will be my new graph. The tangent of 4x will have a period of pi quarters instead of pi. So the graphs will be shrunk significantly, no other changes will be made. So the x-intercepts, obviously, all the x values will shrink, right? So I will have an intercept at 0, and then not again at pi, but at pi quarters, and then at 2 pi quarters, and then at -pi quarters, and then at -2 pi quarters. And instead of having the asymptotes at pi halves, I will have the asymptote at pi eighths and -pi eighths. And then 3 pi eighths instead of 3 pi quarters. So my graph shouldn't cross there. Right? So my asymptotes, your graph cannot touch the asymptotes, 3 pi eighths, 5 pi eighths, etc. Odd multiples of pi eighths, same thing here, -3 pi eighths, x equals -5 pi eighths. That's what's going to happen to this. For 2 times a cotangent of 1/4 x, the b here is 1/4. I will get a new period, pi divided by 1/4, which is 4 pi. It will significantly stretch the graph. So instead of having a graph that has one branch from 0 to pi, now the one branch will be from 0 to 4 pi. The intercept of pi over 2 will be multiplied by 4, so I will have an intercept at 2 pi. The points pi quarter and 1 will have an x value of pi quarters times 4, so I will have a pi and a 3 pi. only the y values here will also change. So a is equal to 2 means that the y will double. So instead of having y equal to 1, I will have at pi a y equal to 2. So that will be my point. And instead of having at 3 pi quarters negative 1, I will have at 3 pi a negative 2. So it will be here. The graph of the new transformation will look like that. And that will be one branch. Everything will repeat every 4 pi. If I want to graph a transformation of a cosecant function, I will graph the transformation of the sine function and then eliminate the sine graph and leave the cosecant. So I want to refresh our memory on how to graph the sine function. It has a equal to 2. It has b equal to 2 pi. It has a c equal to negative pi. And it has a d equal to 3. The amplitude will be 2. The period will be 2 pi divided by 2 pi, which is 1. The phase shift will be negative pi divided by 2 pi, which is negative 1/2. And the midline will be y equal to 3. So y equal to 3 will be here. We have a phase shift of negative 1/2. Quarters of a period are 1/4. So let's put negative 1/2 here, negative 1/4, 0, 1, 1/4 and 1/2. And then let's do some more quarters. This will be the quarters of the period. So this is a sine function. It's going to start here. It's going to go at the highest point in the midline, at the lowest point in the midline, at the highest point in the midland, at the lowest point, here lowest point, highest point. And it's going to do this movement from midline to high and to low every quarter of a period. So that will be a quarter. That is this value that I need to know so that I can sketch the points. Since the midline is y is equal to 3 and the amplitude is 2, this point has a y of 5 and these points have a y of 1. Now, let's put the numbers here. This is 1/4, 1/2, 3/4, 1, 5/4, etc. On the back side, negative 1/4, negative 1, negative 3/4, negative 1/2 here, negative 1 here. Now, how do I graph the cosecant? The cosecant has asymptotes where the intercepts would have been before the transformation. So wherever the sine becomes 0 on the midline. So not on the x-axis. So remember that the x-axis is here, but the midline is where the graph has now transformed. And this is where the sine becomes 0. On the midline, it becomes 0. After that, the graph of the cosecant is asymptotic to those asymptotes, staying on the same side of the midline of the sine function. And if I eliminate the sine curve, I got the graph of the cosecant that is translated. To go in backwards, if I want to find the equation of a secant or a cosecant from the graph, I'm actually going to sketch the reciprocal function. I try not to have a phase shift. So at 0, this function is at the maximum. Therefore, it's going to be a cosine function. So the red curve is a cosine function. I'm looking for a cosine no b x minus e plus d. I don't want, bx, I don't want to have a phase shift, so I don't want to have an e or a c. So bx, and that means that I am going to be describing this graph that I was given as the same a secant of bx plus d. The a's and the b and the d are equal to each other. So I'm looking for this function, f of x equals a secant bx plus d, and I'm going to use its reciprocal, a cosine bx plus d, to determine the coefficients. So the maximum is at 1, and the minimum is at -3. The midline will be the middle of those. 1 plus -3 divided by 2. This is -2 divided by 2. This is -1. So the midline is at y equal to -1. That's the d. And the amplitude is the distance between 1 and -1, and -1 and -3. So that will make a equal to 2. And I'm looking for the period that will determine the value of b. Now, from the max to the next max, the distance is 8. So the period is 8, which is 2 pi divided by b. And therefore, b will be 2 pi divided by 8, or pi quarters. So I will have here pi quarters x minus 1. And therefore, the function I'm looking for will be the reciprocal function with the same coefficients. So 2 secant of pi quarters x minus 1.